from outside the solar system and was the first one that we spotted near the Earth. Unlike any comet or asteroid that we have seen before from within the solar system.
The hunt for extraterrestrial life is picking up speed. But what if, rather than looking for traces of biology, we looked for something more recognizable, such as an extraterrestrial civilization? It has been hypothesized for a very long time that there may be other forms of life and perhaps adventure outside the boundaries of our home planet. Because there are so many different ways that technology could be improved, it is quite interesting whenever something new is discovered. It is impossible to predict which minor discovery will result in a significant development or which major discovery would usher in a new era. Stay with us until the end, because scientists just recently disclosed something really shocking that will make you question everything you know. When Harvard professor Avi Loeb discovered evidence of extraterrestrial activity, it sparked outrage in the scientific community. Is fear and conservatism preventing science from evaluating convincing evidence that aliens exist? The object had already left the solar system by the time humanity spotted it. On October 19, 2017, astronomers at the University of Hawaii noticed an unusual shape tumbling away from Earth. A brilliant speck rushing through the deep black. Informally, they call it Oumuamua, which means scout in Hawaiian, and categorize it as an interstellar asteroid, the first known to enter our solar system. Nobody knew for sure what it was. Asteroids are typically rocky and drab and spherical, but Oumuamua was shiny and elongated. Astronomers initially believed it was a comet, but comets have dazzling gassy tails and there was none here. The more information gathered, the more mysterious the thing appeared. Time after time it looked unusual, astrophysicist Avi Loeb explains via Zoom. At some point it crossed a threshold for me, and at that point you say, okay, come on. In Extraterrestrial, Loeb recounts an eventful period of about 3 years during which there has been a significant amount of discussion. Almost a year after Oumuamua was discovered, he began working on a scientific paper to explain its various peculiarities, its strange geometry, luminosity, lack of a cometary tail, and the strange fact that it appeared to have accelerated away from the Sun in a straight line, out of its orbit, somehow propelled. He'd already published a divisive piece for Scientific American. I said we should consider the possibility of this being technological debris from other civilizations. He did, however, conduct a more thorough examination of the existing evidence. I approach this just like any other scientific anomaly, he says. I rule out possibilities and whatever looks the most plausible is what I put out. That's the way science is done. You just collect more evidence. Soon after, Loeb and Harvard postdoctoral fellow Shmuel Bialy devised a theory. Oumuamua was not an asteroid, comet, or other naturally occurring object. It was a massive pancake-shaped sail, less than a millimeter thick, powered by the sun's radiation. Loeb knew nature was incapable of making such a thing, which pleased him. In Extraterrestrial, he adds, the implication was obvious, that something or someone had created it. As he and Bialy completed their work, they speculated that Oumuamua may be a fully operational probe sent intentionally to Earth's vicinity by an alien civilization. Though they admitted that we'll never know for sure. It's too late to image Oumuamua with existing telescopes or chase it with chemical rockets, the researchers added. Surprisingly, no one had been successful in taking a photograph of the object while it stayed within range, and at this point it was gone. Loeb spent his childhood on a farm not far from Tel Aviv, and even as a little boy, he was fascinated by the profound issues that life presents. Every weekend, he would grab a work of philosophy, Nietzsche or Sartre for example, and drive our tractor to a quiet spot in the hills and read for hours. His mother, who was well known in the community as an amazing baker, was the one who inspired him to read philosophy. In later years, he came to the conclusion that physics rather than philosophy offered him the best opportunity to comprehend the realities of the world. He has looked into things like dark matter and black holes, and he has pondered the question of when and why the cosmos came into being. Because of Oumuamua, he is confident that he has found a viable solution to maybe the most important question of all, which is whether or not there is anybody else out there. Scientists all throughout the world devote years of their lives to finding solutions to life's most perplexing mysteries. This is no different for these two Harvard astrophysicists who have developed a theory on how life might have spread throughout the universe. Despite the fact that the theory was initially met with skepticism, Amir Siraj and Avi Loeb say that their theory should be taken seriously and that it is, if anything, overly conservative in terms of calculating how many times life exporting events from Earth have actually occurred. So back when the solar system was more densely packed, millions or billions of years ago, a massive comet passed near to the outer regions of our atmosphere. It was rapidly moving many miles above the Earth's surface, too high to burn up as a fireball, but low enough to be hindered by the atmosphere. Extremely tough microorganisms were drifting up along its path, and some of them survived the comet's collision. These bacteria ended up hidden deep within the porous exterior of the comet, insulated from deep space radiation as the comet rocketed away from Earth and eventually out of the solar system entirely. It took thousands and millions of years for the comet to end up in another solar system with inhabited planets. Finally, the comet impacted with one of those planets, depositing the microorganisms, many of which are still alive, and establishing a new place for earthly life in the cosmos. It is unknown whether or not this occurred, because there is no substantial evidence to support it. However, the pair of Harvard astrophysicists argue that the depositing of bacteria into a comet, which is then blasted from the solar system, should have occurred not once, but several hundred times during Earth's history. While the theory has been treated with criticism, there are compelling reasons to believe it is plausible. In the 1970s, studies were conducted utilizing a series of tiny rockets to identify bacteria colonies in the high atmosphere. Comets enter and exit our solar system on a regular basis. A big comet could have skimmed the Earth, and because comets are porous, the bacteria could have been protected from radiation. Some bacteria can even survive in space for remarkably lengthy periods of time. Siraj and Loeb hypothesized that this occurred several times, potentially seeding other worlds with life microbes. One famous theory about how life began on Earth involves life being transported here on a comet that fell into Earth, so kicking off life as we know it. Therefore, it's possible that our planet was seeded, or that it was the one that caused other planets to be seeded. In yet another of their recent research studies, Amir Siraj and Avi Loeb suggested that meteorites that brushed the atmosphere of Earth could have transported microorganisms from Earth to Venus. Researchers from MIT, Cardiff University, Harvard, and other universities discovered possible clues of life on Venus in the form of phosphine gas in the planet's atmosphere. Venus looks to be an improbable candidate for extraterrestrial life, with caustic sulfuric acid droplets in its atmosphere and surface temperatures exceeding 800 degrees Fahrenheit. This prompted Loeb and Siraj to speculate that any hypothetical Venusian life might not be alien at all, but rather descended from Earth life. The bottom line is that you could have a transfer of life between Venus and Earth. It's a process that was not considered before, Loeb said. People thought about what happens if a meteor hits the Earth, splatters the rock on the Earth, and then sends pieces of rock flying into space, and they hit Venus. That's a very different process, and it's not clear that life can survive such an impact. According to Loeb, the typical idea of Earth meteorite debris eventually reaching Venus exposes prospective bacteria to more heat and radiation than they can survive. Instead, Loeb and Siraj came up with the concept of meteors that brush against the atmosphere of the Earth. According to Siraj, so then we came up with this idea of grazing, almost like a spoon taking the foam off of a cappuccino. And on top of the cappuccino, these meteors can basically scoop up any microbes that exist in the atmosphere. According to Loeb, a meteor that grazed the surface of the Earth would first enter the atmosphere of the planet and then continue on into space. The meteor would give bacteria with a place to hide from potentially dangerous radiation within its porous pores. Because the meteor is only passing through the atmosphere very softly, it is able to avoid becoming overheated. If an organism is deep inside the rock, it's sort of protected. The rock serves as the spacesuit for these microbes, Loeb said. Loeb and Suraj calculated that at least 600,000 meteors may have flown through Earth's atmosphere and landed on Venus within the next 100,000 years during the history of our solar system. The bacteria they collected on Earth are expected to survive the trip to the neighbouring planet. When the bacteria reach Venus, they will most likely reside in the planet's 35-mile-high cloud layer, which is cooler and less dense than the planet's searing surface. There, the temperature is similar to what we have here in the Earth's lower atmosphere, Loeb explained. So the clouds are habitable in principle, they have the right temperature and pressure, there might be microbes living inside the droplets. Although the meteor grazing concept appears promising, Suraj admits that further investigation is needed. Suraj explained that for this concept to be accepted, researchers would need to investigate the abundance and variety of bacteria in Earth's atmosphere that could have been picked up by meteors. The continuous investigation into life on Venus will ultimately determine if Loeb and Suraj's theory is correct. Let us know what you think about the possibility of life on other planets in the comments section.